What is the history of analog to digital conversion techniques? Imagine trying to listen to a live concert through a tiny radio. The sound is continuous and flowing, but your radio needs to turn that into digital bits to process it. That's where analog to digital conversion comes in. It's a way to take real-world signals like sound, light, or temperature and turn them into numbers that computers can understand. But how did this process come to be? Let's take a quick journey through its history. It all started in the early 1900s when engineers needed better ways to process signals for communication. Back then, vacuum tubes were the main technology. They could amplify signals but weren't ideal for converting signals into digital form. The first major step was the development of pulse code modulation, which sampled an analog signal at regular intervals and then represented those samples as digital numbers. This method was key because it allowed signals to be stored and transmitted more efficiently. In the 1930s, a man named Alec Harley Reeves made a big leap forward. He created a system that digitized signals using just 5 bits of data at a 6,000 times per second sampling rate. His system compared the input signal to a ramp voltage and generated pulses that could be turned into digital numbers. This was a major breakthrough because it showed how to convert analog signals into a digital from that could be reconstructed later. During the 1940s, Bell Labs and International Telephone and Telegraph worked together to develop the Successive Approximation Register, or SAR, analog to digital converter. This design used a binary search method to quickly and accurately find the digital value that matched the input signal. It was initially used for military encryption during World War II, but it laid the groundwork for future digital systems. The invention of the transistor in 1947 was another big step. Transistors replaced vacuum tubes, making devices smaller, more reliable, and more energy efficient. By the 1950s, companies like EBSCO Engineering started making commercial analog to digital converters, like an 11-bit model that could convert signals more precisely. These early devices used discrete transistors and took up a lot of space but proved that digital conversion was possible on a larger scale. As technology advanced through the 1960s and beyond, integrated circuits made analog to digital converters even smaller and faster. Different architectures emerged, like flash converters that could do thousands of conversions per second, and sigma-delta converters that offered high accuracy for audio and instrumentation. These innovations made digital systems more capable of handling real-world signals with great precision. Today, analog to digital conversion is everywhere. It's in your smartphones, medical devices, audio equipment, and even in space exploration. The evolution from simple pulse code modulation to complex integrated circuits has made it possible to process signals in real time, with high speed and accuracy. This progress has driven the growth of digital electronics and embedded systems, turning analog signals into the digital data that powers modern technology. So, from vacuum tubes to tiny integrated circuits, the history of analog to digital conversion techniques is a story of continuous improvement. It's a story of how engineers turned the continuous flow of the world into the discrete data that computers can understand and use every day.